understand between instruments, where are we? Then linked to telemetry, there are those science goals that are relatively easy to do within the allocated telemetry, and there are those that are a bit harder to do. And one day we will have to discuss in detail what are we going to observe on which day, when, and with what telemetry. And to be able to do that, we need this preparatory work. That's question 2 and 3. And then 4 automatically comes out of that. If you cannot do a certain thing, or you need more telemetry for a certain thing, how does that affect the others, and how do we collectively make a good plan? So what happened on Tuesday is that, first of all, Daniel gave us a short overview of where we are with the telemetry, what are the problems, what are the hopes, and the good news is that a detailed analysis report is coming from Astrium later this year, so we'll see when that arrives. Once we have that, we have hard numbers that we can discuss in detail. Meanwhile, we had per instrument, nearly all instruments were there, a short presentation. And one thing that maybe I need to clarify is that all instruments are designed to specs, of course. They are designed such that they can do the observations that are needed to reach the science goals. Now that doesn't mean that it's easy. The sun also has to collaborate. It's not because you can observe that it will happen. And so depending on which science objective that you are looking at, some are telemetry poor and others are absolutely telemetry starved between the science objectives. For example, connection science is relatively easy telemetry-wise in an average sense if you look at the quiet sun and how that influences the average solar wind. But it's really hard if you think of connection science on an event basis. One flare giving one CME, giving one bunch of particles through the heliosphere. That's much harder. Right. In the instrument presentation, it also became clear that compression is widely varying between instruments. Some are not compressing for perhaps good reasons. Some consider onboard processing as a way of compressing, and indeed that's sometimes an extremely efficient way of processing. And then you have the classical lossy and lossless GPEG versions of compression. After that, we had a brief discussion, and I must admit the discussion was not always easy. There were obvious misunderstandings between us, and so I think it was good to discuss, and it's probably good to discuss even more. One of the misunderstandings was what is exactly in the EIB-A. So there is a little table that says so much telemetry for these instruments, and that's this little table. I'm sorry you cannot see the numbers on the left.
Maybe it's just 12. You're all fine.
In any case, you cannot see it from the But the misunderstanding was about what does these numbers mean, because for the in situ instruments, these are averages over the whole orbit, while for the remote sensing, these are averages during the 30 days they are on. But so if you other people interpreted this as in terms of data volumes, which is not the case, because these 30 days is just less than 168 days, and if you correct it for that and you do an average for 168 days for everybody, you get this kind of thing. And I will quickly say it's not my intention to point to a certain instrument. In particular, SWA, they made a good presentation. They explained that they're compressing really hard with the moments of distribution, up to a compression factor in the hundreds. They are in fact different instruments together, so I'm not pointing to them, please. Let's not get into that, but it's that kind of misunderstandings that we had between us. So I think in order to avoid even the conflicts, we need to have a bit of guiding principles on how we discuss further. And these 3 bullets, in my mind, they're dead obvious, but each of them were questioned during the discussion, so it became sometimes a bit surrealistic. I would like to have this approved by you or amended to the minutes or something. We can discuss them, we can change them, but we need a baseline on which we can discuss. The first thing is that we need to accept that telemetry is limited. There is not enough. So every kilobit telemetry that is somewhere spent matters. I mean, we must be able to discuss it. We had several cases where, okay, the telemetry is split into different heaps, instruments, but also spacecraft. And for every single heap, somebody stands up and says, we cannot do better here because we don't have resources, or it's too important, or this data is too beautiful. That might be true, but we at least should be able to discuss it. The second bullet is what Esther brought up. It's obviously not Daniel who is asking to put that in because he's co-authoring this presentation. But obviously the best thing to do is that the total should go up. And I understand it's not always possible to just ask for more and we get more. It's a question of money and the right time has to be there. But I guess sooner or later we'll have to come up with science arguments why we need more. And so at that time I think we should support the project all we can, somehow. At that time it will be clear. Then the EIDA says numbers, and it says these numbers are time averages. It really says so. We don't have to discuss that. What we need to discuss is what the average mean. Is it per day, per orbit, or over the whole mission?
It's written on Swiss.
No.
It is defined.
It says it's an average. It doesn't say over what.
It is defined. I challenge you. If you open the idea, I can challenge you. You can show it whether.
Okay. I closed it. Sorry. You don't seem to be able to do that one.
I wouldn't worry much more right now because of this whole review.
Okay.
Yeah.
Okay, I just want to mention, please, but it
Yeah.
is there. It's absolutely, it says exactly over which time is imaging. 30 days or 168 days.
Yes, that it does say. But what we're after is whether we can have, for example, in one orbit, one instrument doing a bit more,
Oh,
and in the next orbit it does a little bit less. This was refused during the discussion.
no, okay, understand, sorry. No, this of course, since this is not a general rule, but is a plan, the IDA does not deal with this.
Yep.
Then we understand.
Yes,
I mean,
yes.
essentially, there's no
Defined is a simple reference scenario.
Yeah.
Yep.
What the reality can be locally achieved is
Yeah.
quite
So essentially what I try to clarify is that for some historical reason, originally there were always only rates in there, and that always created confusion if the rates were not associated with time durations with which you need to multiply the rates to get a volume. And we just started discussing that, of course. I mean, we have certain data volumes available down there just to make sure how we distribute that appropriately. So the average remains as promised and as designed, that we have a certain flexibility in terms of reallocating based on size parity.
Yeah. So I think that's what we're after. We want to explore the flexibility of the system without hurting anybody's rights or feelings. Sami.
Just clarify the background of this point. It goes back to the last SWT. And so the background of this point goes back to the last SWT, and there will be a slide on that. But the basic idea is that we will at some point, and I think we cannot get around that, and we should just have a discussion on this and agree at this point in time that we can move forward, is that not every orbit is going to be the same. The orbits aren't the same from the mechanics, right? From the places where the remote sensing instruments observe, from the latitudes, from the distance to the sun, etc. Every orbit is different, and so we should also think about if we want to have the telemetry distribution among the instruments fixed in stone, that it will be the same on every orbit. I don't think that makes sense. That is not the best way to get most of the science out of it. And that we should think, we should, I hope, agree that we will have an averaged telemetry per instrument over the mission. But from orbit to orbit, we can vary that in order to get the maximum of science out of it. That's